Hello and welcome to the first round of video notes for 2015. I know you're excited. I'm excited, so let's get started. Okay, so our notes today are over weather and atmospheric movement and the way the atmosphere, how it changes and turns and convects through convection, how that causes local weather on our level, the weather we see. So we're first going to, here on the front of this page, we just kind of have a summary paragraph that we're going to fill in the blanks together. So it says, we know that the earth is heated blank by the sun. How is the earth heated by the sun? What do you think? Is it heated not at all by the sun? Is it heated a lot by the sun? Anybody remember? Unevenly. Unevenly by the sun. And when these different temperatures occur in the atmosphere, it causes the air to have different, what do you think? What two things could go there? Different temperatures can also cause different what in air or water, or in the lava lamp. The different temperatures that happen in the lava lamp changes the densities. And also, if you change the density, then you're changing the pressure. We know that air with low pressure and density is what? If it has a low pressure and a low density, then does that mean it's cooler or warmer? That means it's warmer. And if it's warmer, then it's going to rise. And the opposite of that would be air with high pressure and density is not warmer, cooler, and it's going to sink. As the air around the earth moves through, what's the process called? That describes how the air moves. Because of the different temperatures, the rising and the sinking, up and down, what's that called? Not conduction, not radiation, convection. Global weather patterns are formed, and then these interactions produce the local weather conditions we see and feel. So let's scoot the page down a little bit more. So we're going to fill in the boxes here together. In this box, I want you to draw air particles that would sink. These are particles that have a high density, a low temperature, and a high pressure. And in this box, I want you to draw particles that would rise. These are particles that have a low density, high temperature, and low pressure. So go ahead and fill those out. If you need to pause the video, you can. Okay, let's fill those out together now, or rather check what you have on your paper. In this first box, if it's high density particles, that means they're going to be packed really close together. It's going to be really, really dense. So we want to draw all the particles really close together. Okay, and then the opposite, in this box, particles have a low density, then they're going to be really far apart. They have a lot of room to move, and that's why they're going to rise, because they're very light, so they rise. Okay, and then also over here in the corner, it says, we know temperature is measured with a thermometer, but air pressure is measured with a barometer. This is what a barometer looks like. It kind of looks like a compass. It has a glass front, and the air pushes on that glass front, and when it pushes on the glass front, it changes the dial on the inside, so it reads the air pressure. Okay, if you will flip your paper over to the back now, let me get this straight. So now we're going to talk about those global weather patterns that are happening all over the world, and we're going to talk about how those affect our local weather patterns. But first, in the atmosphere, I found a little clip there with atmosphere, because these global patterns are things that happen in the atmosphere. Okay? So air moves around the globe under the influence of a few patterns. Firstly, the Coriolis effect. The Coriolis effect is because of the rotating, the spinning of the earth on its axis, it causes air and water in the northern hemisphere to move to the right or counterclockwise, and air and water in the southern hemisphere to move to the left or counterclockwise. So we're just going to fill in those arrows in the northern and southern hemisphere. So in the northern hemisphere, draw the arrows going clockwise, and in the southern hemisphere, just draw the opposite, going counterclockwise. Okay, another global pattern that we see that affects our weather is global winds. Global winds. So starting here at this middle line is the equator. And north and south of the equator we have what are called the trade winds. Okay, the trade winds, and they very much affect weather, especially here in the United States because we're near the equator. So the trade winds. So we're just going to draw the direction of the trade winds. So the northern trade winds, remember everything has to go clockwise in the northern hemisphere. They go from east to west clockwise. And then in the southern hemisphere, they go from west to east. I'm sorry. They also go from east to west, but they go counterclockwise. Okay, and then above and below the northern and southern trade winds are the winds called the westerlies. I have them labeled right there, the westerlies. And they go from west to east. It's weird. They're named after the direction they come from, not the direction they're going. So the westerlies go from west to east. So they are going to go like this in the north, and then in the south, they're going to go like this. Okay? And then lastly at the poles, we have the easterlies. They're also called the polar easterlies. So these winds blow from the east to the west. We're going to literally copy these same arrows we did for the trade winds, because they have the exact same pattern. Okay? And then on top of that, the strongest winds we see on the globe are called the jet streams. There's 2 jet streams in the northern hemisphere, 2 jet streams in the southern hemisphere, and they're named the same thing. The ones closest to the poles on the outside is called the polar jet streams. So polar and polar. And then the 2 closest to the equator are called the subtropical jet streams, both of them. So that's easy to remember. Okay. And then next, we're going to talk about how these global patterns cause movement in the air masses. So we're going to look at that air masses section here. It says, there are big blobs of air around the globe called air masses. Each mass has characteristic temperature, pressure, and moisture. However, they're labeled by their pressure. Under pressure. We're under pressure. So let's see. We have a high pressure system and a low pressure system. High pressure systems, when you see them on the map, when the weatherman shows these to you on the map, they're colored blue. It's with a blue H, so you're going to color that H blue here in a minute. High pressure systems move clockwise, and it's when they have high pressure systems have cooler and dry air, and they bring clear skies and sunny weather. So here I left a blank. I want you to fill in what kind of temperature of air do you think there is in a high pressure system. If it's cool, dry air, not what kind of temperature, what kind of movement do you think this air does? If it's cool and dry, do you think it's going to rise or sink? If it's cool, dry, think about it in the lava lamp. When it gets to the top, it cools off, and then it does what? It sinks. So here, with a high pressure system, the air is going to sink because it's cool and more dense. Excuse me. And then in a low pressure system, when you see a low pressure system on the map, it is with a red L. So here in a minute, you're going to color this L red. I'm sorry, my cat's on the table again, if you just saw his tail there. Anyways, you're going to color it red. It moves counterclockwise. So high and low pressure systems move in opposite directions. Low pressure systems move counterclockwise. Low pressure systems have warmer, humid air, and they bring stormy weather events. So opposite kinds of weather here. So if high pressure systems have cooler air and they sink, low pressure systems have warmer, humid air, then what do you think is going to happen to the air in a low pressure system? Is it going to rise or sink? Think about in the lava lamp. It heats up on the bottom, it becomes warmer, and that causes it to rise. So air in a low pressure system is going to rise. Okay, and then let's move over here to fronts. This is our last little section. This video hasn't been too bad, right? So fronts are the things that cause the local weather we see. It says as air moves around these pressure systems, it causes air with different properties to meet, which forms a front. Kelly Clarkson knows about fronts, maybe. Okay, anyways, a warm front. I drew a picture here. This is what happens with a warm front. It's when warm air moves in and meets a cold air mass, and because warm air is less dense, it rises above the cold air. So it rises above. The warm air is always going to go up in both of these fronts. You can see the warm goes up here and the warm's going to go up here because we learned when we talked about convection, warm things always go up because they have a lower density, so they're always going to rise. So anyways, when you see a warm front on a weather map, you're going to see a symbol that looks like this. They kind of look like half circles. And my classes last year could remember that this was the warm front because it kind of looks like the sun rising and setting, and we know the sun is warm or hot, so they would remember that this looked like the sun, so they knew this was a warm front. Now when you see a warm front on a weather map, like on the news or whatever, you're going to see these half circles, but they're going to be red, so that's going to be a good indication to you that it's for a warm front. But on your STAR test, you won't have a color, it'll just be in black and white, so you'll need to know the shape. The half circle is a warm front. So here, like I said, it's when there's already a cold air mass existing and warm air comes in and meets the cold air mass and rises above it. So here's the description here. Let's fill out these blanks. This says when blank air moves towards a cold air mass. So what kind of air did we say moved toward the cold air mass with a warm front? That would be warm air. When warm air moves towards a cold air mass and the blank above the cold. And what does it do when it gets to the cold? It rises or moves above the cold air. And when this happens, it causes clouds and then clear skies. When you have a warm air mass, it causes clouds and clear skies. And we know that it's going to cause clouds because you should remember when, like from learning the water cycle, when water gets warm, it starts to evaporate, it comes up and it cools and condensates and forms clouds. So when the air cools and condensates, it forms clouds. Oh my gosh, there's my cat again. I'm so sorry. He just loves these videos. Okay, we're almost done. So now let's go down and look at cold front. And here in a second, you're going to color these air masses too. Cold front. So cold front, the weather symbol are triangles, pointy triangles, and they're colored blue when you see them on a weather map. But like I said, on the STAR test, you'll have just black and white, so you won't have color. So you'll need to remember that triangles means blue. In my classes last year, remember that a cold front was triangles because they're pointy like icicles, and icicles are cold. So warm front, they look like half suns, which are warm or hot, and cold front, they look like pointy icicles, which are cold. So here in a second, you're going to color that. So what happens with a cold front is kind of the exact opposite. You have a warm air mass that's already existing, and a cold air mass comes in. We know cold air, it has a really high density and a high pressure, and so it hits that warm air mass really hard and pushes it up. It pushes it up really fast. So it causes very quick temperature changes because it pushes that warm air up real fast, so the temperature changes really quickly, and sometimes it'll bring some rain just because this is kind of a harsh change, and so it causes a little bit of showers. So here for the description, when blank air moves towards a warm air mass. So here's the warm air mass. When what kind of air moves towards a warm air mass? It's going to be cold. When cold air moves towards a warm air mass and quickly pushes the warm air up. Okay, So now you're going to go back. You need a red matte pencil and a blue matte pencil. Color the cold front, symbols blue, the warm front, symbols red, the high pressure system H blue, the low pressure system L red, and then you can color these air masses shown in the fronts too. Color the warm ones obviously red, and the blue ones and the cold ones obviously blue. Okay. And
ain't no sunshine when she's gone.
Ain't no sunshine. Well, if there's not any sunshine, then what kind of weather does that mean we're experiencing? Are we having a warm front or a cold front? If there's no sunshine, who knows it? A cold front. No sunshine. Some showers. Okay, good job. Goodbye.